Today, I'm going to show you how to create a post-process cartoon outline shader in Unreal and in Unity. Let's go. So last week I mentioned that we'd be doing a crepuscular rays shader today, but I ran into some challenges with that one and it was only going to work in Unity and not in Unreal, so I decided to do something else. I hope you don't mind. So way back in episode 39, I showed a couple of methods of creating the ink outlines for toon shaders. One method was in the shaders of each individual object, and a second method that I showed duplicated each individual mesh and turned the duplicates inside out. At the end of that video, I mentioned that it was possible to do cartoon ink effects as a post-process step, but I didn't explain how to do it. Today, I'm going to fix that. Before we jump into how to make this outline shader, I want to briefly talk about what we need to do so you'll understand what's going on once we start throwing nodes around. In order to add these outlines, we need to detect where the edges are in the scene. And there are actually two different kinds of edges. One kind of edge, like the outline around the edges of these chairs, depends on a difference in depth. So you can see that this chair is relatively close to the camera, but the sky behind the chair is significantly further away. So if we look at the pixels right along the edge and measure the pixels around them, we can find that there's a big change in depth between the chair and the sky behind it. And so what we're going to do is sample the 4 pixels around each pixel on the screen. And if there's a big change between those pixels, we're going to mark that as an edge. Now in this case, we're talking about depth. But let's take a look at this table here for a minute. You can see that there's an outline right here on the edge of the lip of the table, but there's not a change in depth. And the way that we're creating this outline is by detecting a change in normals. And so what we're going to do is we're going to detect changes in depth and changes in normals, and we're going to use both of these methods to create these outlines. Okay, let's go ahead and jump right in and start creating this cartoon ink outlines shader. So I'm going to come down here to the bottom of my materials, right click and create a new material. And this one I'm going to type test post-process detect edges. And we'll double click and open this up and start creating our shader. The first thing that we need to do is set our material domain. We don't want to create a surface shader. We want to create a post-process shader. So I mentioned in my description that we want to sample the 4 pixels right around the pixel that we're currently drawing on the screen. So in order to do that, we need to find the pixel that we're currently drawing and then find the pixels around it. So I'm going to create 4 vector 2 nodes, and the way that I do this is just by holding down the 2 key and clicking. So I'm going to create 4 of these, and these represent the offset required for each of our pixels. So this one's going to be -1 and 1. This one's going to be 1 and -1. This one's going to be 1 and 1. And this last one's going to be -1 and -1. So this represents a 1 pixel offset from the center, where the pixel that we're currently rendering would be 0, 0. So the pixel that we're currently rendering we can represent with screen position. And we can just take this viewport UV value here, and we need to offset that based on each of these offset values here. Now, we do want to make the effect just a little bit more flexible, and so I'm going to multiply each of these by a hard-coded value that I might choose to expose later as a parameter, but I'm just going to hold down 1 for now and create this value here, which represents how thick we want our outline to be. So if I connect this, I know it doesn't make any sense to multiply something by 1, but eventually this is going to represent our edge thickness, and I can change this to 2 or 3 to make our edges thicker, because it's going to push these neighboring pixel values further away. So I'm just going to go ahead and copy this multiply node, and we're going to wire each of these up together. So we're going to multiply each of our neighboring pixel distances by this hard-coded 1 value here that later on we'll be able to adjust to increase our edge thickness if we want to. Okay, the next thing that we need to do is take these 1 values and make them into actual pixel sizes. And the way that we can do that is we can divide the value by our screen resolution. By the way, we're going to do a lot of copying and pasting in this episode because we have to do all these things 4 times, 1 for each of the 4 pixels around the pixel that we're currently rendering. All right, so I'm going to grab a node called view size, and this represents the width and the height of the screen that I'm currently rendering. So if I divide this value here by the size of the view, it's going to give me a value that is the size of an individual pixel on the screen. All right, so now I've got an offset of 1 pixel in this direction, another pixel in this direction, and then these other 2 directions, and this is going to give me the 4 cornering pixels that neighbor the pixel that I'm currently rendering. So now if I take my viewport UVs here and I add the pixel offsets to them, what this is going to give me is the correct UV coordinates for each of the 4 pixels that are neighboring the pixel that I'm currently rendering. And great, so I'm all set, and we're ready to use our offset screen coordinates to go ahead and render, or to go ahead and sample our pixels. So let's just move this over here just a bit to give ourselves some more space. And the first kind of edges that we're going to detect are the ones that use differences in normals. So we're going to add a scene texture node. And we're going to drop this down, and we want to pick a world normal. Now, just to show you what this looks like, I'm going to wire, just for now, I'm going to wire our color into our emissive out here, and I'll hit save. And let's switch back to our scene, and I'll go ahead and add this shader, just the progress that we've made so far. I'm going to go ahead and add this shader to our scene so that you can see what the world normal looks like. So here's the shader we just created, test, post-process, detect edges. And when we add it, now you can see that instead of rendering our scene, we're actually getting normal data from our scene. Now, I don't know if you can see it because of the YouTube compression, but our scene is jiggling around a little bit. And what that means is that this shader is happening just a little bit out of order from where it should be. And so we need to go ahead and correct that. So to correct this like 1 pixel jittering that it's doing, I'm going to select my root node here and come down to the settings, to the post-process section, and instead of after tone map, I'm going to set this to before translucency and go ahead and save that. And now the rendering that I'm doing gets the, you can see that it's kind of adjusting now so that it gets tone mapped. And that's actually kind of wrong in this case, but we'll fix it. But what this is doing is the screen is going to now get the temporal anti-aliasing applied to it instead of being rendered before temporal anti-aliasing and then jittering all around. All right, so we've got our world normals here. But what we really want is to sample our world normal using the 4 pixels around our current pixel. So I'm going to go ahead and wire the 4 pixel UVs, and I'll copy paste our world normal sample here and use each of the UVs for these 4 neighboring pixels to sample my world normals. All right, now that I've got those, I need to go ahead and compare them to see if there's a big distance between each of these normals. And before I do that, I need to compress them. Right now, the normals are in -1 to 1 space, and I need to shift that space into the 0 to 1 space. So the way that I do that is I'm going to multiply by 0.5, and that takes the space to -0.5 to +0.5. And then if I add 0.5 to it, now my range is going to be from 0 to 1. And this is the range that I need in order to compare the normals with each other. So I'm just going to go ahead and do this process for all 4 of these. Great. And now I need to compare the pixels with each other. So the way that I can do that is with a subtract. And so basically I'm just finding how different they are from each other. And once I've done that, I can add an absolute node so that if they're different in the negative direction or the positive direction, it still detects that as an edge. So I'm going to compare these 2 normals with each other, and I'm going to compare these 2 normals with each other. And then I'm going to add the results together. And let's go ahead and plug this into our output emissive and see what we get as a result. All right, so that looks pretty cool. We've got some kind of psychedelicness going on here. And basically what we've done is detected areas where there's a big difference in normals, or where the normals are changing a lot. Everywhere where you see white edges, that's where there's a really high change in the normal. Now, what we want to do, you can see that there are lots of different colors going on here. What we want to do is find out which of our 3 channels of the color values that we've gotten here is the largest, and then just return that. And that's pretty easy to do. All we have to do is split out our channels. So I'm going to add a split component here. Now we've got our color channels as red, green, and blue. And I can just add a max node. And then I can compare red and green. And that's going to give us the one that's higher. And then I'll add another max. So the maximum of the red and green compared with the maximum, compared with blue. So this little combination here is going to give me whichever of these 3 channels is the highest. So we'll go ahead and plug that into our output emissive color, save it, and switch back to our scene. Now you can see I've got just the outlines showing, and I need to do just a little bit of adjusting so that I get only outlines instead of all this extra stuff. But I am making good progress. You can kind of see where this is going. All right, so in order to do these adjustments, I need to add a couple of values that, again, eventually I could expose these as tweakable parameters, but I've kind of got them set right now to a spot where they work pretty well as just hard-coded values. And so I'm just going to go ahead and leave them this way. You can expose these values later if you want to, but I'm just going to leave them as hard-coded values for now. So what I'm going to do is add a smooth step node. And I'm going to blend between 0.2 as minimum. And then the result of adding 0.2 and 0.5, which obviously would be 0.7, that's going to be my maximum. And then I'm going to plug in my result here. Now remember, I was getting all kinds of grayscale values here where I have nice white edges, but I'm also getting these grayscale values. And that's what I'm trying to get rid of by using this smooth step here. So Now that I've plugged my value into the smooth step, and I'm using 0.2 as the minimum and 0.7 as the maximum, now let's take a look at the results that we get from that. All right, sweet. So just doing that little adjustment got us almost all of the way there to our toon outlines. That is looking pretty cool. But right now, all I have is the outlines, and they're just white. I have successfully found my edges, but now I need the rest of my scene, and I need to make my outlines black. So let's go ahead and move on and do that part of the process. So I'm going to move my root node over to give myself a little bit of space. And in order to get the rest of my scene, I'm going to need a scene texture node again. And this time I'm going to set my scene texture to post-process input 0, which is just my regular rendered scene. And I need to blend between that and black using this as my mask. And so in order to do that, I need to add a lerp node. So I'm going to type interp and grab the linear interpolation. And now I'm going to plug in, actually I'm going to hold down the 4 key and click. And this is going to give me a vector 4, which is defaulting to 0, 0, 0, 0, which is the same as black. And now I can use this white toon outline to blend between my scene and my my black. This is going to be the color of my outlines. So I can connect my smooth step in there to blend between my scene and my black color, and then wire that in as my output emissive. And we'll switch back and take a look at our result. Woohoo! Yeah, that's pretty sweet. I've got my outlines going on, and that is just fantastic. I love it. Now, there are a couple of things that we can do to improve it. For one thing, if I wanted to tone down my outlines so that they were subtle, I could multiply this value by an opacity number. So let's add a constant value and give it like 0.2. So you can see, you remember that the value coming out of here, wherever the outlines showed up, it was white. But if I multiply that by 0.2, the maximum brightness it's going to get is 0.2. And so mostly I'm going to be getting my scene color. This is basically like an opacity value or a translucency value for my outline. So I'll go ahead and save that. And boy, I don't know if you can see it now, but my outlines are still there. They're just really subtle. So if I turn them off, I don't know, maybe 0.2 is a little too large of a value because I can't see. Let's crank this back up to maybe 0.65. Yeah, so now I've got my outlines, but they're just a little bit more subtle. You can see if I toggle these on and off. So if you want some really light, subtle outlines, you can tweak this opacity value that I've created here to kind of control how opaque or transparent your outlines are. Okay, I mentioned toward the beginning that it was good to have both normals and depth. And so what we're going to do next is go ahead and create the part of the shader that measures differences in depth. So obviously, in order to do that, we need scene depth nodes. And so I'm going to create 4 of these, and we're going to sample the scene depth using our 4 neighboring pixels of our current pixel. So I'll go ahead and wire these in. And now we need to do the same thing that we did with the normals, where we subtract this depth pixel from this one, and then take the absolute value. And I'm just going to copy and paste these two so we can do the same thing with these two depth pixels. And now we can just add the results together, just like we did with the normals. And now with depth, we need to do something just a little bit different. We need to take our result and divide it by whichever depth is the largest. And so to do that, again, we can take the maximum of these two depths, and then again, the maximum of that in our third depth, and then the maximum of that and our fourth depth. So this is going to take the largest of the four depths, and we're going to divide our result by that. And that's going to help to kind of normalize our results so that wherever we're measuring differences in depth, it's relative to the deepest depth in the scene. Then I can take the result here and just saturate it to make sure that it's somewhere between 0 and 1. Let's go ahead and take a look at the results that we're getting from this depth compare here. So I'm just going to wire this directly into my emissive color and save it. Now if we take a look at our results, you can see the edges that our depth is detecting. And obviously our automatic exposure here is brightening up our scene. But you can see wherever there's a big change in depth, it's making those nice white outlines. Just like we did with the normals, we want to get rid of the grayscale values here and just leave ourselves with what's left over. So once again, just like we did here, I'm actually going to copy this set of nodes and paste them down here. We're going to do the same thing to process our depth values that we did with our normal values. In this case, I'm going to give this value 0.1, and the same thing with this value. I'm just going to give it a 0.1. So I'm finding the values that are between 0.1 and 0.2 and making that my entire range. Okay, now I can take, well, let's go ahead and wire this in and take a look at the result. And then we'll combine the results together with both our normal compare and our depth compare. Okay, you can see with our depth compare, we're getting nice outlines wherever there's a change in depth. But like I showed you before, where the front of the table here is, there's no change in depth in that spot. And so we need the normal compare results to give us that value. Okay, so now I can compare my my normal detect edge value and my depth detect edge value. And I'm going to do a max here. So whichever of those values is greater, that's the value that we're going to end up using. And so I can wire the result of that max operation into my my multiply here, that where I'm controlling the opacity. And then if I want to take a look at my combined result, so here you go. Now I've got outlines that are nice and solid because they're taking into account changes in both depth and in normal. So I've got the edge of the front edge of the table here that's being added by my normal compare, and the back edge of the table that's being computed by my normal and my depth compare. So I'm getting some really nice edges. All right, and then I can add those, or then I can use those edges to blend between my regular scene and my black color where the edges are. So there we go. That's how you create cartoon edges using a post-process shader. Now, if I want to, I can do all kinds of tweaking. I can tweak how much or the range of the normal compare that I want to use. I can tweak the range of the depth compare that I want to use with these two values. I can tweak the color of the outline with this value here. Like I can use my color picker and give myself some nice blue edges if I want to. There's my scene with Nice cartoon blue edges. You can see that the edges show up around every leaf on this bush. And yeah, so this is pretty great fun. Now, there's one issue that I might want to point out here, and that is once you get kind of far away, the edges tend to bleed together. And so I have a control here that controls how thick the edges are. Right now it's set to 1. And I might want to control this value here based on distance from the camera. I'm not going to get into that today, but that's something that you might want to experiment with, making the edges kind of thick when the mesh is close to the camera, and then thinning them out further away, and then maybe even dropping them completely once you get too far away from the camera, just so you don't end up with a mess like this where the edges are all bleeding together. All right, so that's how to create toon edges in Unreal. Let's switch over to Unity and I'll show you how to create the same effect there. All right, here we are in Unity, and we want to go ahead and create the same shader here to create our toon ink outlines that we did in Unreal. So I'm just going to go ahead down here in the project and pick Create Shader Graph, HDRP, and we're going to create a full screen shader graph. And we're going to call this Test Full Screen Edge Detect. I'm going to open this shader up and get going. So just like we did in Unreal, the first thing that we need to do is create the nodes that we need that represent the pixel offsets. So I'm just going to create 4 vector2 nodes here. I'm going to give it the values of -1 and 1. And the values of 1 and -1. And 1 and 1. And finally, -1 and -1. So we've got all 4 pixels that represent the corners around the pixel that we're currently rendering. In order to give ourselves the control to offset these and create thicker edges, I'm going to go ahead and multiply by a hard-coded value. And we're just going to default this to 2 for now. This controls how thick my edges are going to be. So I'm going to multiply each of these offset values by my float value down here. I'm just going to go ahead for now and maximize this just so that we can make it as clear as possible. So I'm going to copy my multiply node here and just paste it a couple of times, one for each of these pixel offsets. All right, and then we need to divide by the size of the screen. So I'm going to add a divide node, one for each of these. Then we need to add a screen node, which is going to give us the dimensions of our screen. And we need to combine these together. So I'm going to create a vector2 node again and just wire my width and my height into that vector2 so that the width and height are the 2 components in my vector2. Then I'm going to divide each of my pixel offset values by the screen dimensions. And what that does is it makes these pixel offset values into the actual size of pixels on the screen. So I'm going to clone my divide here. So I've got 4 of them. So each of my offsets become offsets of actual pixels on the screen. All right, and then the last thing that I need to do is use a screen position node to get the coordinate of the pixel that I'm currently rendering. And then I need to add my offsets to that so that each of my 4 samples gets offset in the correct direction from the pixel that I'm currently rendering. And boom, there you go. I've got the coordinates that I need to sample both my normals and my depth. So in order to sample my normals, I'm going to add an HD sample buffer here. And this allows me to sample a whole bunch of different things: normal, smoothness, motion vectors, etc. But I'm going to sample the world space normal. Now again, if I just wire this directly in, we'll be able to see the world space normals of our scene, which is pretty cool. Let's switch back to our scene now. And instead of this completed version, let's go ahead and poke in the new version that we're working on. All right, there we go. We've got some pretty cool looking normals here. So we're showing what the world space normals look like, and you can see that our effect is being rendered before we're rendering all of the particles and the transparent objects. Okay, so what I want to do is sample my normal 4 times using these texture coordinates that we've just created. So I'm sampling the normals of the 4 pixels right around the pixel that I'm currently rendering, so that I can compare them and see how much difference there is in between them to know. So if there's a lot of difference, we obviously know that we're on an edge. So before I can compare my normals, I need to adjust them so that they're in the 0 to 1 range instead of -1 to 1. So to take these to the 0 to 1 range, I need to multiply by 0.5. And then I need to, and that's going to take it to -0.5 to +0.5. And then I need to adjust the range again by adding 0.5, so it switches it out of the negative. And that's going to move it to the 0 to 1 range. So for each of these, I'm going to multiply by 0.5 and add 0.5. So I'm just going to go ahead and take these nodes here and copy and paste them for each of my normal samples. And then, in order to compare these normal samples with each other, I just need to subtract. So I'm subtracting one sample from the other to find out how much of a difference there is between the two. And then I take the absolute value, which will give us either a positive or a negative result to show us how far away this normal is from this normal. Now I can do the same thing with my other 2 normals. I'm just going to subtract one from the other and then take the absolute value, and then the results that I get from both of these compares, I can just add those together, which will give me the overall difference between all 4 of my normal samples. And then the last thing that I need to do is right now this is a 3-channel comparison, and I just need to figure out which of those 3 channels is the highest. So I'm going to add a split node to split the channels into individual red, green, and blue. And then I'm going to find which one is the greatest just by finding the maximum value of my first 2 samples and then taking the result of that and finding the maximum value between that and my 3rd sample. Now I've got the results that are, whichever of those 3 channels is the greatest, that's the one that I'm going to keep. So let's go ahead at this point and take a look at what we've found, or what the results are from comparing our world space normals. So I'm just going to wire this directly into our output here, and we'll take a look at the results in our scene. Okay, you can see that our little find edges algorithm is doing a pretty good job of finding those areas where there's a change in normal. But we do have a lot of grayscale values in here. So we've got some nice white edges, but we also have some gray values, and we want to get rid of those gray values. So we can do that with a smooth step. So I'm just going to go ahead and add a smooth step node. And I'm going to wire the results coming out of here into the input port of my smooth step. And then I need to add edge values here. So for my first edge value, I'm going to give it a value of 0.2. You know what? Actually, I need to do a little bit of math here. So I'm just going to add a float value and give this a value of 0.2. And then I'm going to give myself another float value. And this is going to be the other value. Here I'm going to give it a value of 0.5. And I'm going to add these two together. And the sum of my two input values is going to be my edge 2 input. But my edge 1 input is just going to be this first one here. So 0.2 or the two added together, which is a result of which would be 0.7. Obviously, these two added together here. Now, if I wanted to, I could expose these as parameters, but right now I'm just going to leave them as hard-coded values just so that we can move along with the explanation. You can go ahead and create Blackboard parameters for these to allow you to adjust them outside of the shader, but I'm not going to do that for now. So let's go ahead and save it and take a look at our result. Now you can see that that smooth step operation that we did has done a pretty good job of getting rid of those grayscale values and just leaving us with the nice white edge outlines here. So that's pretty cool. Now if we want to take this and go ahead and finish it up, what we need to do is take this value that we've generated and give ourselves a lerp node. And we're going to use this mask value that we've generated as our lerp T input to blend between A and B. Now for A, we want the HD scene color node. This is our just our standard scene pixel that we've rendered. And then for B, we're going to want a color. So let's go ahead and add a color node. And we're going to leave that color as black. So we can wire that in there. And we're going to blend between our scene color and our edge color using this edge detection algorithm that we've created here. All right, and then we can just take that and wire our results into the base color of our fragment program. And I'll hit save, and we'll switch over to our scene. And we're getting bad results. I must have made a mistake. Yeah, I created a scene depth node here instead of a scene color. So let's go back and add an HD scene color node. And we got to remember to check this exposure box. We'll wire that in instead of the scene depth. Hit save. Back to our scene, and cool. Now we're getting some nice edges here. You can see if we toggle them on and off, you can see all of the places where there's some abrupt changes in normals. We're getting those nice cartoon edges. Now if I come back here, if I want to make my edges a little bit thicker, right now we've got a value of 2. Let's crank that up to 4 and switch back. Now you can see I've got a little bit thicker outlines here around everything, where I was getting thinner ones before. All right, that's maybe a little bit too heavy. Let's maybe tone it down to 3. And you might not want a value of 3 for your final product, but for this demo, it makes them stand out pretty nicely. All right, now the other thing that we need to do is do the same kind of edge detection, but with scene depth this time instead of with the normals. So let's go ahead and add our scene depth node here. And just like we did with the normals, we're going to need 4 of these. And we'll sample them using the pixel offsets that we computed earlier. Now we're going to find the differences in depth here by subtracting one depth value from the next. And again, we'll take the absolute value of that because whether it's a large difference one direction or the other direction makes no difference. So we want the absolute value. And then I can copy these nodes and do the same thing with comparing these two depth samples here. And then finally I can take my results and add them together. And now I want to find which of my 4 depth samples is the largest. And we're going to divide the final result by the largest sample. So I'm going to take the maximum of my first 2 depth samples and then connect that to a second maximum node, wire in my 3rd depth sample, and then wire that into my last depth sample here. And this is going to tell me which of my 4 depth samples is the furthest or the largest. And then I'm going to divide my result here by that largest sample. And then I'll saturate my result just to make sure that I'm staying between 0 and 1. And that is going to give me that's my edge detection for the 4 depth samples. So let's go ahead and wire this into my output result and see what I get from comparing the 4 depth pixels. Okay, you can see some nice spots where I'm getting some depth detection. There's kind of a gradient on the floor here, which is a little bit concerning. But let's go ahead and apply the same kind of adjustment that I was doing to the normal values here using my smooth step. So I'm going to go ahead and copy these nodes here, my 2 float values, my add and my smooth step. And I'll paste these down here. And then wire the result of my depth compare into my smooth step. Now in this case, I want to give myself values of 0.1 and 0.1. And then let's take a look at the result that we're getting after we've adjusted our values to be between 0.1 and 0.2 here. So I'm just going to wire these into the result and hit save. Now you can see we're getting some really nice depth values in places where the comparison of the normals wouldn't normally show up. So we get some pretty cool results comparing both normals and depth. So I can just take the results of both of these and wire them into a maximum. So whichever of these is greater, that's the one that we're going to use. And let's take a look at this. So now this is a nice combination of where the edges are being discovered based on the normals and being discovered based on the differences in depth. So you can see we got some nice white results, but then we can wire that into our lerp node and blend between our HD scene color and the color of our ink outlines based on the maximum of the differences in the normals here and the differences in the depth here. So we're using both of those to find edges, and then we wire the result in. And there you go. We've got some really nice looking cartoon outlines in Unity as a post-process effect. This is really useful if you're creating a cartoon style game, kind of like Borderlands, or any of the various cartoony games that have been released recently. But yeah, there you go. Pretty cool. So this is what it looks like without the toon outlines, and this is what it looks like with them. Now, back in episode 38, I talked about how to create the paint effects. Right now we're using realistic looking inside shaders, but cartoony looking outlines, and that's a little bit incongruous. So if you wanted to go ahead and create shaders that created the paint effects, you could jump over and look at episode 38. I'll link that right here. Well, that about wraps up today's video. Thanks everybody for watching. I know this is a little bit of a long one, but I hope you enjoyed it and that you learned how to create these cool toon shaded outline effects in Unreal and Unity. All right, we'll see you next week, everybody. Have a good one.